All right, we should be good to go. Feel free to start whenever you're ready.
All right, uh, welcome to our workshop on artificial intelligence and the other wonders of technology. So, without further ado, let's get on with this workshop. So, this is the table of contents of what we'll be talking about in this workshop. So, we're going to start off with talking about tech and how it's advanced, and then we're going to be talking about what exactly AI is. And then we're going to be diving into some interesting and unique applications of AI. Some you may have already heard of, or some may be unfamiliar to you. And then we'll be moving on to our conclusion. All right. So, in today's fast paced world, technology plays a vital role in our daily lives, and it definitely has the power to change the way we live, work, and communicate. This can range from artificial intelligence, machine learning, to the Internet of Things, and 5G. So the advancements in technology have really opened up a world of possibilities and have made our lives easier and more connected than ever before. And and now in particular, I wanted to talk about one technology, blockchain technology. And by the way, the intro that I just did was actually made with an AI script. So that's pretty cool. And uh, anyways, moving on to blockchain technology. Uh, in brief, it is a technique for storing records and this makes it hard to hack the system or fabricate the data stored on it. And this makes the data safe and unchangeable. And it uses DLT, which is distributed ledger technology, and that is a digital system for simultaneously recording transactions and related data in numerous locations. And the data is stored in blocks that are linked together in digital chains in a blockchain database. And blockchain technology is suitable for delivering that information since it provides real-time, shareable, and transparent data. Anyways, I won't be going too in-depth into this, but if you want to know more about blockchain technology, I will be leaving a link to this where you can learn more about blockchain technology in the chat towards the end of the workshop. So moving on.
Okay, so I'm going to be talking about artificial intelligence, which is a new technology that has the potential to be as big as electricity, right? It has the potential to change like almost every single industry we work with. So first, I'll be talking about what it is. So AI, I'm sure you've heard this term before, but just to go over it, AI is basically trying to simulate human intelligence, right? So we all have brains, hopefully, and what we're doing is essentially there's an input, like let's say I hear your voice. That's a stimulus. It comes into my brain figures out what to do, and then it says, okay, hey, just reply back to this person, right? And that's basically, it's pretty similar to what AI is trying to replicate, right? So it's basically just a computer trying to replicate intelligence. And the reason why is because a human computer has certain advantages that humans just don't, right? Like, let's say, for example, you wanted to have a machine learning algorithm, right? I mean, you can't have a person who ranks every single post on a website from worst to best based on every single user, right? That's just infeasible. So AI is much faster. Um, it's much more reliable. It can make less errors than humans, and so it's just much better at doing a lot of stuff. So now I'll be talking about how. I'll actually show like a live coding example of this right now. But basically, this is a very popular. So you can see these are handwritten digits, right? And so what happens is we're gonna feed this in to something called a neural network. And so you can kind of think of this. This again is pretty similar to your brain, right? So this is a subset of AI. which is trying to mimic exactly how your brain works, right? So your brain has neurons that are connected to each other the same way a neural network, you could tell from the name, it's kind of inspired by your brain, has, again, artificial neurons that are linked to each other, right? And then they give an output. So I'll show an example of this. One sec. Yeah, okay. So this is just a Jupyter notebook. What's that? Okay. So this is basically kind of like the hello world of machine learning, right? Neural networks. So what we're going to do is we're going to try and identify like these digits. Okay. So first, what you do is you import like your libraries. Now, I'm sure you're familiar with some of these, like NumPy, Matplotlib, especially if you're into Python. But the ones that are really important for the machine learning part are two called TensorFlow and Keras. And if you want, you can like look up the documentation. These are two of the most like popular models used for machine learning, right? Like TensorFlow, it's actually like Google backed, right? And they also have like libraries like TensorFlow JS. So if you want to use it in like your front end, I don't recommend it because on the front end, you want it to be like as fast as possible, right? Like if you want a user to load a website, you don't want to have them running locally a whole neural network. But still, you could use it in your front end if you would like. There's an API for tons of functions. Same with Keras. So yeah, check those out if you want to. Then Keras has, so what I'm doing here is Keras has a built-in database called MNIST. And MNIST is the name of this data set. It's made by these people at like NYU, Google Labs, stuff like that. And basically, it's just a collection of hundreds of thousands of handwritten digits. I'm not going to download them because like it's going to be a really huge file. But MNIST, so Keras, you're allowed to load the data because it's like built in. So you could see it's just like a built-in method. So that's what I'm basically doing here. And yeah, so this is the link. If you actually want to check this out, just open this and yeah, it'll prompt you to save the file. It's probably like a few gigabytes though. So just be warned. So what we're doing here is, as you can see, there's 4 variables, right? So there's xtrain, ytrain, xtest, and ytest. And so these two are grouped together, the trains, and the tests are also grouped together, right? So the training data is basically what we're gonna change this neural network based on, right? So as you can see, there are like little arrows in this neural network, right? And basically all these arrows do is like, let's take the first neuron in the input layer, okay? So it's gonna be linking to all the neurons in the second layer. Okay, now each of these connections, each of these arrows is gonna have a number associated with it, right? And that's basically just going to tell you, okay, what should we multiply this first neuron by? Okay, so like let's say the first neuron's value was like 0.7, and the first neuron in the first layer, the first neuron in the second layer, their arrow had a value of like 0.5. Then basically you would multiply those two, and that would be the value in the second neuron. And then it keeps going on and on until it reaches the final layer. That's basically how a neural network works, like in a very simplified way. So these are the data sets we're going to be changing these values on. And then the test data is just to see how well our model actually does. So the length of the train data is 60,000. So, I mean, quite a lot. So 60,000 hand-drawn images. And if you could see the shape, you'll see that it's an array of 28 by 28 pixels, right? So I've drawn the image here. So you could see Matplotlib shows that it's 28 pixels by 28 pixels, right? So each digit will be these many pixels. But this is actually not a good thing to train your data on. And the reason is it's much easier to work with an array, like not a non-nested array, right? It's much easier to work with one that's just 784, right? So instead of 28 times 28, it would just be 784, right? So essentially that's what we're going to do here. Okay. Now this we're dividing by 255, and I'll try and explain to you why again. So okay, let's see here. I just print x train or something. X train of 0. Okay, so you'll see. Okay, give it a sec. So you'll see that a lot of these values are 0, but they go from 0 to 255, right? So they go from, so 0 means, in this case, completely white, and 255 means, in this image, it would be completely black, right? The problem is it's very hard to work with numbers between 0 and 255, and it's just easier to work between 0 and 1, right? Because all your neural network neurons are going to be based from 0 to 1. Okay, so it's just easier. So if you divide this by 255, you'll get the same ratios, right? It's just that now it's between 0 and 1, right? That's the entire reason that in the next step, we're dividing by 255. Okay, so again, that's what these are doing. So the train and test data, we're dividing by 255, and the shape is still the same. Okay, this doesn't change anything about the shape of the individual models, right? Because all we're doing is changing it from 0 to 255 to 0 to 1, right? So it doesn't change the actual shape of the data. Now to do that, Keras has a built-in reshape function, which is quite useful. If you ever have data that's not in the right type. So what you do is, so in this case, it takes in all these X trains, and it's going to change it from 28 by 28, and it's going to change it to 784, right? 28 times 28 is 784. You can just type that in, but I was too lazy. So essentially, now these two variables are just going to be the exact same things, but instead of being a nested array of 28 by 28, it's just going to be a single array with 784, right? So if you run it, yeah, so you could see that the shape of the new variable is just 784, right? Now this is just like, I made this for a visual representation of what the data looks like. I mean, so for example, this is the first training data. This is the second, so this is very clearly a 0. This is the third, very clearly 4, and then on until like 60,000, right? So this is what really matters here, right? So this is like the actual model part. So Keras has a method called sequential. Now there are many ways you could actually do this, but I find sequential is just the easiest to do. But yeah, so what you do is each of these, so these 4 are going to be layers, right? So you see this one also has, okay, this one has 5 layers. So ours is just going to have 4, right? So the first one is always going to be the input layer. Okay, so the first layer is going to give our image pretty much, right? So this is just taking the image in. It's kind of like a stimuli for your brain, right? So that's why you see it's keras.layers.input. And then the shape is 784, because again, it's pretty hard to work with nested arrays, right? So the second and third layers, now you could have more layers, you could have less layers, but these are both going to be like just traditional, like multiple hidden layers, right? So in our case, instead of 3, we have 2, right? And the reason for that is that if we just went directly from the hidden layer to the output layer, it wouldn't be as accurate, right? It wouldn't be able to account for as many details. Like you can write a 1 like this, you can write a 1 like this, like the other way. You can write a 1 completely straight. Like if you just have 2 layers, it's not going to be able to figure out all that nuance, right? So yeah, and then these are the number of neurons in each layer. Now again, I'm sure you could tinker with this, make it 100, but 1,000, I mean, it's bigger, but it'll also be more accurate. And then the second value, the second parameter passed into this layer is the activation function. Now I'll actually show you what sigmoid function. Yeah. Okay. So it's like a lot of math. But yeah. So essentially, sorry. What it's doing is, like I said before. So each neuron, what it'll do is it'll multiply the value before it and the value of like the arrow, and that's how it gets its value, right? So all sigmoid does is it takes that value and it like squishes it between 0 and 1, right? That's pretty much all it's doing, right? And it makes it like a smooth curve, right? So it's not going to be linear. That's basically all sigmoid is doing. There are a bunch of different activation functions. They all do pretty similar things. I don't really think it matters which one you choose. But the final layer is also incredibly important. So this, again, it looks pretty similar, but it's very important that you get this number right. Okay, like these two, okay, maybe I could have done 100. This one is very important. It's because what the model is going to return is basically just 10 values in this case, right? Let's say it has 0 0.02, 0 0.03, 0 0.5, 0 0.9, 0 0.01, dot, 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 right? So it's going to have 10 of these. Okay, now this one will correspond to the chance that the model thinks the value is 0. Okay, so if it thinks the value, like the image, is 0, it'll make this like 0.9 or whatever, right? This will correspond for the probability it thinks it's 1, 2, etc., right? So for this one, it should, hopefully, have the second value as the highest, right? Because the first value is 0, the second value is 1. Right, so that's why you need to have 10 final layers, because there's going to be 10 values in the output, right? If you were trying to categorize all digits from 1 to 100, then you would have to have 100, right? So this is very important, this number right here. And then basically here, all you're doing is you're compiling it with a bunch of different stuff. So first off, metrics, I mean, it's easiest to explain. So when you're training the epochs, I like to see the accuracy, just so you can see like how good the model is. So in this case, it would be like 94.4%. Now the loss function, what it's basically doing is it's trying to minimize this value, just like loss 0.3795. Try to make that as small as possible, right? Because this is essentially how bad your neural network is, right? So the lower you go, there's like some hardcore calculus going on here that I don't want to bore you guys with, but yeah, so it's basically just trying to minimize this function. And the optimizer is, again, associated with this loss function. Again, it's mostly like deep differential equations and stuff. So yeah. Now model.fit, this is actually important. So what you're going to do is you're going to call it with your X train data and your Y train data, right? And epochs are basically the number of times it'll reiterate over all of the data, right? If you want to see, oh wait, I'll actually show you how. Actually, first I'll run the model. So this might take a while because it's going through like, what was it? 60,000 images 5 times. So it's going to like 300,000 images and trying to classify all of them. So it might take a bit. Okay, during that time, I'll explain like the rest of it. So this was, we trained it on our training data, right? But now we want to see how good it actually is, right? And to see how good it actually is, remember we have that test data, right? So test data is stuff that it's never seen before. And so if it can classify this part right, then, you know, it's probably pretty accurate. So again, all this is doing is testing how good it is with data it's never seen before. And then the prediction is basically just, it gives you, in this case, I'm not entirely sure what the length is of X test flattened. But whatever it is, it's going to give you a nested array, and it's going to give you the predictions for all of these, right? So let's say X test flattened had 10 images that it's never seen before. 1 of a 3, 2 of a 5, whatever, right? So it would give you the predictions of all of this data, right? And then I'll show you like how it actually does. It's taking a lot longer than I'd hoped. But you can see it's, wow, it's doing pretty well, actually. I did not expect this. 97.4%. So the industry standard, I think, is like 99.7%. So if your model can get that good, then like it's considered good enough. Mine probably won't be industry standard because so you could see that it's a very big jump from the first epoch to the second, then a smaller jump from the second epoch to the third. It'll be an even smaller jump from the third to the fourth. And eventually you get to a point where your like code, it just like probably won't get much better. It's just like diminishing returns. So yeah, I guess I will wait for it to train. I guess I could show you some of the test data until then though. Like this was a really tricky one I found. That last time when I tested, the model thought it was an 8. I mean, I can kind of forgive it for that, but the actual value was a 3. I mean, I can understand how the model would mistake it, but yeah, still. This one's doing much better than the last one though. Last time I had like 94% accuracy. This one has close to 99, which is actually really, really good. So yeah, I think, okay, 14 seconds. Okay, so, okay, it's done. So now we'll see how well it does on like data it's never seen before. All right, let's hope it does well. Okay, so you could see that the accuracy, so this is stuff that it's never seen. It's classifying them, right, like 97.4% of the time, which is not bad. So I'll try and show you like, so what it's doing. One sec. Okay, so this is basically the prediction, right? So it's a nested array, as you can see, and they're like, I don't even know how many. Wait, let me check the length of X test flattened. Okay. Yeah, so there are 10,000 test images. Okay. So basically, that was a nested array of 10,000 images that it classified, right? And these are ones that it's never seen before. And you could see that for each of these, like let's say I'll just take the first one. Yeah, so you could see that for this, it gives 10 values, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is the probability it thinks that for each of them, right? So there's a probability it's 0, there's a probability it's 1, etc., right? So if you want, I'll show you the test 0, right? Okay, so this is test 0. It's a 7. And you can clearly see here that the 7th value is this one. And this is 0.9999 because e to the power minus 1, right? So it's very confident this is a 7. So I think it'll probably get this one right. So if I just run this, yeah, so our prediction was a 7 and the value was a 7, right? So at this point, you're pretty much done with the model, right? Now, if you wanted to export this to like your front end, let's say you wanted like JavaScript or something, then you could just run this function, model.save. It'll probably be a pretty big model, but you could just store this in like some cloud bucket server, like, I don't know, like Google Cloud servers, AWS, whatever, and then just call it from your front end. You could do that. There's this APIs. So yeah, all you have to do is load it in the front end. You don't actually have to run it every single time, which is quite nice. So yeah, like I can just show another example. So yeah, so this I hopefully it guesses 2. Yeah, so 2, and I'm sure there are ones that it gets wrong, but yeah. So so that's pretty much how a how you make, sorry. Wow. Yeah, so it's pretty much how you make a neural network to do pretty basic things, but you could do it to get much more complex things if you wanted to, like some of the applications we're going to talk about later. So yeah, now to get to the applications of AI. So this is one I'm sure you've all heard of. It's called ChatGPT. It's very famous, like got 1 million users in 5 days or something like that. So I wanted to see how well it would do in like programming, right? So I asked it to make something pretty simple. Code a Python script that uses like this API, because it's like the free one, to display the stock price of a stock ticker entered by the user. Okay. And this is actually wrong. I like you can't do this. Because first off, this function just does not exist. Okay, so one thing you'll notice about ChatGPT is it's good, but it's very confident in the way it answers, right? So it can very blatantly give like false information. Like this is just completely wrong. This function does not even exist. Like this function global quote, I don't know if you can see it, but this is like literally not there in the API, right? So it completely like lied to me, right? So yeah, and then so you have to tell it. So this is why I don't think it'll replace like programmers, right? I mean, it's still not like at the level where it understands a lot of stuff. Like I had to manually tell it, okay, you have to use this time series, and then it figured it out, right? And also I told it to implement error handling, just in case. But again, wait, let me try and pull it up. So, okay, so let's say this is the API, okay? So what it was trying to do is, as you can see, it was getting the time series 1min, then it was getting the 0th element, and then it was getting the close. So I'll just show you what that is. This is the time series 1min, okay. But then you can't get the 0th element from this because it's not an array, right? So again, it's just saying things that are very obviously wrong, right? So again, I had to tell it, okay, in this line, the 0 does not work because it's an object. And then it said it, and it ended up working, right? If you want, I can show you. I think I pulled it up on like, one sec. It's on like Replit or something. Wait. Oh. Okay. I don't know where it is, but I'll just create a new one. Okay. Copy code. Okay. So I already have an API key, so I'll just comment this out. Where was it? Here. Okay. So like, let's say we have any stock ticker, right? Like, okay, let's take Apple. Okay. So you can very clearly see the code works, right? The problem is it was wrong like a few times, right? So I think ChatGPT, it's a very good tool. Like, for example, I didn't have to code anything, right? But you still have to have some basic coding knowledge to like guide it in the right direction. It's not going to do like all of your work. I don't think it's there yet. Maybe in the future, but yeah. So this could be a really useful tool to like boost your productivity, right? Because I did this in like what, like a minute or two. So yeah, that's pretty nice. So now Ashwin will be talking about some of the other applications of AI.
All right. All right. So another application of AI is this website called Runway ML. And this website basically has 30 AI magic tools, as they call it. And they're pretty pretty good for everyday usage. And it could be good for your profile or entertainment purposes. And I would say especially it's the most useful for content creators. So anyways, let's go over these features. So it has a ton of features, as I mentioned earlier. Anything from like blurring backgrounds to adding green screens to adding live subtitles when you put a video. And I've actually tested out two of these features, but obviously you guys can go through a lot more of these, and I've tested a lot more of these as well, and they're actually pretty cool, but some of them are inaccurate. But anyways, let's go to the first feature that I tested. So this magic tool that they called was erase and replace. So as you can see, I gave it a image of a basketball court and a basketball on it. So you could essentially highlight the area which you wanted to replace. So in this case, I highlighted the basketball, and you could input anything you want it to be replaced with. So I inputted a tennis ball, and it didn't take too much time. I would say around 10 seconds or 15 seconds. But within that short period of time, it managed to get a pretty realistic looking image of a tennis ball on the court. But as you can see on the bottom of the image, it says 4 out of 4. So this is the fourth image that it generated. It generated like around 4 images similar to that one, and uh, this is the only image which I found really realistic. And the other images, either it didn't seem right or the tennis ball, it was another type of ball. So yeah, it does get inaccurate results at times, but I would say for the most part, it is a pretty cool tool. And uh, also in this case, you can see the background is kind of blurred as itself. Like that's how the image was. So it will definitely be a lot harder for this tool to work on backgrounds which have similar colors and no contrast. Yeah. So, anyways, moving on to the next tool that I used. So this is frame interpolation. So yeah, as you just saw in that video, uh, what happens in frame interpolation is the AI magic tool. I gave it two images. So the first image, which you see at the beginning of the video, is a cloud, and is a clear sky, and then towards the end of the video, it shifts to a night sky. So I give it an image of a clear sky and a night sky. And you can give it any time duration you want, transition to last. And it essentially animates these two images into a smooth transition to form a video. So uh, it doesn't look the best. It's not the smoothest animation, but yeah, it definitely does work and it seems pretty cool. But but again, these are two similar images like clouds. Both are skies. So if you try to blend two completely different images, like let's say uh, a basketball court and a sky, that gives quite weird results. So it only works for images which are similar. Anyway, moving on. Yeah, so this is another website, uh, and it's called Codiga. So it's basically this extension that you can add to any IDE, and it gives you code analysis in real time. So it's a great AI tool for all you coders. And yeah, so there's features, four main features that that Codiga really covers. So the first one being static code analysis. So Codiga has a set of rules from its hub, and you can in fact design your own static code analysis rules within 5 minutes. And then uh, this works in VS Code, uh, GitHub, GitLab, a lot of other IDEs, and it auto fixes code in a click, and it also it analyzes your fixes within the IDE. Moving on to custom analysis rules, which is a pretty cool feature of Codiga. So you can basically create your own code analysis rules from your browser, right? And then you can ask your code, and then that set of code that you make will follow that set of rules. So, and you can create this and share this new code analysis rules with other people. and you can share it publicly on the Codega hub. So, and you can also take rules from the Codega hub as well and share it. And again, you can have a team project where you share these rules and rule sets within your set team. And then there's automated code reviews. So basically, this is pretty simple. It just gives instantaneous code reviews and recommendations in seconds. So as you can see in the image, it just gave a safety issue of not to use string in the MySQL because it leads to SQL injections. So that's pretty simple right there. And lastly, a simple yet effective tool, code snippets. So you can create and share these smart code snippets with the world or on the Codega hub, or you can do it with your team. And yeah, that's pretty much it. All right, so we hope you enjoyed our workshop. Just a bit about our company. We are the Weekly Fortune, and we are an article company. And our company, we find discoveries in tech, finance, and politics. And if you like this workshop or like what we talk about, you can go ahead, visit our site, theweeklyfortune.com. I'll leave a link to that in the chat, and it's completely free, and all you need is your email. And it would help us out a lot. And you could sign up to our tech, finance, or politics newsletter. And yeah, that's basically it for the workshop. We hope you had a good time. I'll leave the link in the chat right now.
Alrighty. Thank you so much. We can send these to our Discord if you like, our community. And also, are you guys okay with us posting this on our YouTube channel as a recording?
Yeah, sure.
Sounds good. Thank you so much for hosting. We really appreciate it.
All right, thank you.
Thank you.